Good morning, students. In today's section, we are going to discuss about the electromagnetic spectrum, its uses, how they produce their wavelength and frequency. So, first we are going to discuss what is meant by electromagnetic spectrum. Then we will be telling the production, how different electromagnetic waves are produced, what are its wavelength and frequency, what are its uses. This is the important topic about electromagnetic waves. So, in this chapter, this is the most important topic. So, you have to study the production, the wavelength, the frequency and also its uses. So, I have made this in a tabular form so that you can understand it easily. Electromagnetic spectrum. So, what is meant by electromagnetic spectrum? The orderly distribution of electromagnetic waves based on their increasing order of frequency or based on their decreasing order of wavelengths is called electromagnetic spectrum. So, the orderly distribution of electromagnetic waves in the increasing order of frequency or the decreasing order of wavelengths based on their properties, based on their physical properties and their uses. That is actually called electromagnetic spectrum. So, I have arranged the electromagnetic waves in the increasing order of frequency. Okay. So, the first one is radio wave, then microwave, infrared, visible light, ultraviolet, X-rays, gamma rays. So, there are 7 components in the electromagnetic spectrum: radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays and gamma rays. So, let us see each one of them. So, the first one is radio waves, and what is the wavelength? A few kilometer to about 0.3 meter, that is the wavelength, and the frequency ranges from a few hertz to 10 raised to 9 hertz. So, you can just think like this: the frequency range is almost about 500 kilohertz to 1000 megahertz. That is what we commonly use. Okay, just make a note of that: 500 kilohertz to 1000 megahertz. What is the source of radio wave? Oscillating electronic circuits. Oscillating electronic circuits can produce radio waves. So, you can just think like this: the accelerating charges, we just discussed how waves are produced, accelerating charges. So, I am just saying like this: the accelerating motion of charges in conducting wires or oscillating circuits, those can produce radio waves. Then how can that be detected? They can be detected with the help of receiving antenna. You know, to receive FM radio, in all our cars we have a metal rod which is called antenna. In our mobile phone, our headphone jack will act as the antenna. So, by receiving antenna we can receive the radio waves. What are the main uses of radio waves? The first use is they can be used in radio and TV broadcasting. So, to broadcast radio and TV signals, we use radio waves. And second one, it can be used in radio astronomy. Okay, radio astronomy. So, remember that. So, here I have written only radio and TV broadcasting, and write one more thing: radio astronomy. Now, the second thing is microwave. Microwave is having the wavelength ranges from 0.3 meter to 10 raised to minus 3 meter, and the frequency ranges 10 raised to 9 hertz to 3 into 10 raised to 11 hertz. And the microwaves are also produced by oscillating electronic circuits, but that is the general term. You have to mention the specific term for microwave production, and that is klystron or magnetron valve. I will write it here. Klystron. Klystron or magnetron. These are the two devices which we produce microwave. And you know, a microwave is used in microwave ovens. In microwave oven, to produce microwave, we use magnetron. In radars and all, to produce microwaves, we use klystron. So what are the, how can it be detected? They can be detected by using point contact diodes. So just write that microwaves can be detected by using point contact diodes. What are the uses of microwave? Microwave is used in radar, and I already told microwave is used in microwave ovens, and then it is used in the analysis of fine details of atomic and molecular structure. So to study atomic and molecular structure, we use microwaves. Okay. Now the third thing, third wave is infrared. Third is infrared, and the wavelength ranges 10 raised to minus 3 to 7.8 into 10 raised to minus 7 meter, and the frequency is ranging from 3 into 10 raised to 11 hertz to 4 into 10 raised to 14 hertz, and this is produced by vibrating molecules and hot bodies. Infrared rays are produced by the vibrating molecules and hot bodies. Okay. Now, how can infrared waves are detected? Please write that. It can be detected by using infrared photographic films, thermopiles and bolometer. Thermopile and bolometer. Those are the devices used to detect infrared radiations. Now, what are the uses? Infrared waves are used in industry, medicine, astronomy, night vision cameras, greenhouse, and revealing secret writings on ancient walls. So you already know about infrared photography. You can use infrared rays to photograph the distant objects during a haze climate. If it is mist or fog, you cannot see the other side using visible light. But if we use infrared waves, we can take the photograph of those things, those objects. Infrared photography. And again, infrareds are used in night vision cameras. So that you already know, in our school we have many night vision cameras, and surrounding that you can see certain LEDs. Those are infrared LEDs. So they will produce infrared waves, and we can use that for night vision. So the main thing is infrared waves are less scattered when compared to the visible rays. Okay. And one more thing, infrared rays can be used to treat the muscular cramps. You know, we will apply heat if there is any muscular cramp or something. For that purpose, we can use infrared radiations. Okay. Now the next, visible light. We are very much familiar about the visible light. So its wavelength is ranging from 7.8 into 10 raised to minus 7 meter to 3.8 into 10 raised to minus 7 meter. And frequency is ranging from 4 into 10 raised to 14 hertz to 8 into 10 raised to 14 hertz. And it can be produced by atoms and molecules when the electrons are excited. So we already know when electrons receive energy, they will excite from ground state to the higher energy state. And when they jump from higher energy state to the lower energy state, they will emit radiations in the form of visible region. Okay. Now, how can we detect? the visible light? The first thing is using our eye. Then we can use photographic film and we can use photocells, photographic film or photocells to detect the visible light. And what are its uses? They are used in optics and optical instruments, and they are used to view everything surrounding us, and they are used in photography. Then the next thing is ultraviolet rays, UV rays. So the wavelength is ranging from 3.8 into 10 raised to minus 7 meter to 6 into 10 raised to minus 10 meter, and the range of frequency is 8 into 10 raised to 14 hertz to 3 into 10 raised to 17 hertz. And how UV rays can be produced? Atoms and molecules in electrical discharges. UV rays can be also be produced from sun. So we will say like this, I just say one more word, just note down: inner shell electrons in the atoms. Inner shell electrons from the atoms. When they move from one energy level to another energy level, they will produce UV rays. Okay, inner shell electrons. Now, UV rays can also be detected by photocells and photographic film. And we already know sun produces UV rays, and there is an ozone layer which protects us from the harmful UV radiations. So what are the uses of UV radiations? Medical application, sterilization. We already know killing bacteria and germs in the foodstuffs. We are always using water purifier in our home. There we are having a UV lamp which kills the harmful bacteria. So it is used to kill bacteria and germs in foodstuffs. Then the next use, it is used for detecting invisible writings, forged documents, fingerprint, etc. So in our forensic laboratories, we use UV light. In our currencies, if we hold the currency under UV light, you can see if it is fake currency, it will be displayed. Otherwise, for the actual currencies, some invisible writings will be displayed. So based on that, you can just see whether the currency is fake or real. And we can detect the forged documents and fingerprint, etc. by using UV rays. And UV rays exposure in high amount is harmful to our body. It can cause skin cancer. That is why it is always told you should not go under hot sun, especially from 10 to 3. You should not go under hot sun, because UV radiations will be more. So if you are going out, you can use UV protection creams, and better you use UV protection umbrellas. So the next thing is X-ray. X-rays, 10 raised to minus 9 meter to 6 into 10 raised to minus 12 meter is its wavelength, and its frequency is 3 into 10 raised to 17 hertz to 5 into 10 raised to 19 hertz. And X-rays are produced by inner or more tightly bound electrons in the atoms. Okay, so you can say it is produced by inner shell electrons or more tightly bound atoms. Okay, and X-rays can also be produced by using X-ray tubes. So please note that here, by using X-ray tubes. X-ray tubes. Now, X-rays can be detected by using photographic film and ionization chamber. Now, you already know X-ray can penetrate our flesh. So it is used to take the photographs of our bones. We can see whether the bone is cracked or not. So that is X-ray photography. Then it can used to treat the skin disease and tumor. X-rays can be used in locating cracks and flaws in the finished metallic objects. We will pass X-rays through that metallic object. If there is any crack, X-ray will strike there and reflect back. So thereby we can understand where is the crack. Then detection of smuggled goods in bags of a person. Example, when you pass through, when you go to the airport, they will scan our bags. We have to keep our bags and it will be undergoing an X-ray scan. So you can see whatever things, all those things inside our bag. Then X-ray is used to study the crystal structure. Okay, studying crystal structure is by X-ray. And we told one more thing. For molecular structure and atomic structure, we are using microwaves. For studying the crystal structure, we are using X-rays. So please note that difference. Then the last thing is gamma rays. Gamma rays, they overlap the upper limit of X-ray. So it comes under 10 raised to minus 10 to 10 raised to minus 14 meter. And the frequency is about 3 into 10 raised to 18 hertz to 3 into 10 raised to 22 hertz. And gamma rays are produced by the radioactive decay of a nucleus. When a nucleus undergo radioactive decay, they will produce gamma rays. So I just wrote radioactive substance. You can write radioactive decay. Radioactive decay of the nucleus. Radioactive decay of the nucleus. Now, gamma rays can also be detected using photographic film and ionization chamber. What are the uses of gamma rays? The first and the foremost use is treatment of cancer, radiotherapy. So in radiotherapy, we either use X-rays or we use soft gamma rays. Mostly we are using soft gamma rays. Then it will give information about the structure of the nuclei. So remember that crystal structure can be studied using X-ray. The nuclear structure can be studied using gamma rays. And they are also used in astronomical research. So astronomical research to study about the nuclear structure and for radiotherapy, treatment of cancer. So mainly there are 3 uses. So please note that also. So that's all about our electromagnetic spectrum. This is the most important topic from this chapter. So you have to study the wavelength, frequency, production, detection and also the uses. Mostly the questions comes from this topic only. Okay. Usually a 3-mark question will be asked from this topic. So in this year we are having more MCQs also. So please study this topic properly. With this, our chapter comes to an end. Thank you.